Okay, so our next tool in the pecking order of measuring tools is going to be a micrometer, and this is where you're going to get your most accurate diameter readings from. And there are different types of micrometers to do different things. Okay, so here's a regular outside digital mic. Here's a regular outside micrometer that is graduated in 1/1000th of an inch. Here's a regular outside micrometer that is graduated in 10/1000ths of an inch. It has an extra Vernier Scale on it, which we'll show you. Here's a depth mic, which is graduated in 1/1000th of an inch, and an inside micrometer, which is graduated in 1/1000th of an inch. So this is for measuring the inside diameter of a bore or some sort of hole. This is for measuring the depth of something, and these are measuring for measuring the outside diameter of something. So we'll start with the outside mics first, and then we'll go into the other two. Okay, so we're going to start off with the digital micrometers, which are the easiest to read. Just like the digital caliper, whatever this shows here is your reading. Unfortunately, the batteries in these are dead because I really don't use them, and I don't have a battery to replace these at the moment. But they work exactly the same, and you can do millimeters or inches, and you can also reset your zero on them. But digital calipers are not all created. Digital micrometers are not all created equal. Even though these are both Mitutoyos, they're completely different, and I'll show you. This one here, okay, you can see its resolution is 1/10,000th of an inch. So that's the smallest that it can measure is 1/10,000th of an inch. Okay, yet the resolution of this one here is 5/100,000ths of an inch. So this is a next order of magnitude more accurate than this one here. Now, would you ever have to, in a home shop environment, measure down that low? Probably not. You probably won't even have to measure down into a 10,000th of an inch. You can see how accurate that these things can get, and these are ones I would absolutely trust to be dead on. Now, even though this has markings on the barrel, those really mean nothing. You want to go by the digital display. Yeah, this will be zeroed out, but this barrel is only graduated in thousandths of an inch, and obviously the resolution of this is 5/100,000ths of an inch. So. But those are digital mics, and those are very easy to read. So let's go to the next easiest one to read, and we'll take a look at three different kinds of, three outside mics that have different stop mechanisms on them. Okay, so these are three different mics, and they all do pretty much the same thing. But I just want to show you three differences between this. Now, these come in a variety of sizes. These two are 2-inch mics. This is a 1-inch mic, and the largest mic I have is a 6-inch mic, and they go way bigger than that. So these two are graduated in 1/1000ths of an inch, and I'll show you how to read those first. And this one here is graduated in 10,000ths of an inch with a Vernier Scale, just like the Vernier caliper. Now, the one thing I just wanted to show you is this has a regular thimble on it, meaning that this is just, you tighten it up against the part, whatever you're reading. And basically when you read it, you want to open it up here so you can slip the part in. You're going to be having it this way in your lathe, and you just want to kind of feel where you're going with it until you kind of feel those anvils tighten up on it, and you can give it a little twist and you'll be able to feel where the high spot is and where you're stopping. So right there, and you can see I can fit that whole piece in and out of there, but it drags as I do it, so I know I'm touching all the way around, and that's when I read the scale. So this one here is just a regular thimble. It's just knurled. There's nothing special about that. This one here has a ratchet thimble. You can see it ratchets. So what that's for is just equalizing the pressure on the part. So when you take multiple measurements, the biggest thing with these is you kind of want to put, just like the calipers, you want to put the same amount of pressure on them at a time, at at each reading. So you get this thing set, and then you'll be able to just hit the ratchet thimble there, and that'll let you put the same amount of pressure on it for each reading. This one here, on the other hand, same idea, but instead of having a ratchet thimble, it has what's called a friction thimble. So you'll see here, you see how the barrel's moving there, and when it stops you can see that the barrel's not moving, but that thimble, the knurled part, is moving. So that's how it evens the pressure out on the part. So let's take a look at this one here first and see how to read this. Let me move these out of the way and we'll zoom in. Okay, so we're going to be using this mic for demonstration purposes of reading it. So this is a 2-inch micrometer here, okay? So on every micrometer, well, on most, not every, but on most micrometers, the barrel throw, the barrel travel is 1 inch, okay? So we have to add, you can see if we run this all the way in, I have a 1 inch gap here at the end. Alright, so we have to add that 1 inch to whatever measurement we get on the barrel. So it'll be 1 inch plus whatever is on here. Alright, if this was a regular 1 inch mic, then whatever we would read on the barrel would be our measurement, if you get what I mean. So let's take a quick zoom in here and see how this barrel here, see how it looks, and kind of turn it towards you guys. Okay, so you can see now this goes from 0 to 10, so 1 full inch. Each graduation on the bottom, each line is 25 thousandths. Each line on the top here is 50 thousandths, okay? And then you can see on the barrel here, it's graduated from 0 all the way to 0 again, so 25. There are 25 increments on the barrel. So the easiest way to explain this, or the easiest way to think of this, is think of this central line here, this right here, as a pointer. Okay? So I'm gonna set this micrometer for 400 thousandths, just to show you how this works. I'm going to tighten it down so you can see. Okay, so this micrometer is set to 400 thousandths right now. So here's 1, 2, 3. You can see we're in line with 4. The edge of this barrel is in line with that, the line on 4, and this central line is pointing right at 0. So that's exactly 400 thousandths. So between here and here is 1 inch and 400 thousandths, because this is a 2-inch mic, okay? So I'm going to unlock this, and we're just going to spin it out to an arbitrary measurement right there, okay? And I'm going to lock it down. So now we're going to read that. So we're past 5, 25, we're past 25, we're past 50, we're kind of close to 75, but we're actually past it because the zero's down here. This central line is pointing pretty close to the 6. It's just shy of the 6. Now this is only a the divisions on this micrometer only go up to 1/1000th of an inch. So we're going to estimate the closest thousandths, which is going to be that 6. So to read this, it'll be 575 plus 6. So 581. 1 inch 581 thousandths between this anvil and this anvil. So now I'm going to throw a little bit of a curveball at you, and we're going to do this. Okay, there's 5 inches, 25, 50, and we're right on 75, right? But we're pointing below the 0, so we actually haven't made it to that 75 mark line yet, Okay, this is 50 and 24. So it's actually 5 inches, 574 thousandths. So between here and here is 1 inch, 574 thousandths. Now even if we were, say, here, alright, we look relatively halfway between here and the 22 and 23, we can estimate that as a half a thousandth, since we can't read, our resolution only goes to a thousandth of an inch. We can interpret tenths, but we can't actually read tenths. So I'm going to go to the 1 inch mic that we can actually read tenths at and show you. Okay, so here is a 1 inch micrometer, and it looks pretty much almost the same as the other one, but this one's actually graduated in 10,000ths of an inch. And you can see we have another scale on the side. We have a Vernier scale that goes from 0 to 10. Okay, you see that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 to 0 again. So that is how we read in between a measurement. So, right there, there's 100 thousandths, there's 100 thousandths, there's 200 thousandths. We're a little over 200 thousandths by this center pointer here. So we're 200 thousandths, 201, and somewhere between 201 and 202 thousandths. Okay? So now we turn it to the Vernier scale on the side. And just like with the Vernier calipers, we want to line up a line with something here. So we start looking around, and to me, that 5 lines up perfectly right there. That 5 lines up with this line here. So we're actually 201 and 5/10. So 201 and a half thousandths basically. So if we were to write that down, point be 0.2015. And those, like I said, those tenths are basically just like the Vernier calipers. Alright, let's take a look at some different versions of micrometers. Okay, there's one other thing. Before we get on to the other types of micrometers, there's one thing I wanted to show you was adjusting these. Now this is a 2-inch mic, so what you would have is what's called a standard, which I don't have one, but it's basically a block that is exactly 1 inch that you would put in here. So you'll be able to crank this sucker down on that 1 inch block and make sure that it zeroes out at 0, 0. Okay, if it didn't, then what you would do is, you can see right on here, there's a little hole and they give you a little spanner wrench. You could put that spanner wrench in there, in that hole, and turn this barrel, and that would, until the 0 lines up with that line. The 1 inch ones are easier because all you would do is just shut it completely, and if the 0 didn't line up with the line, you would just adjust it to do it. And that's how you would adjust a micrometer. Okay, so this here is a Starett Depth Mic Set, and it goes from 0 to 6 inches. Right now I have the 0 to 1 inch rod in here. Now, just like every micrometer, or most micrometers, the barrel throw on this is 1 inch. The way you change the actual size of the micrometer is by replacing these rods. So the way this would work is, so you would want to measure the depth from the top to the hole here to the bottom. You would put that right in there, tighten this down until it hits, and then read, just like every other micrometer, read it off there, and that would give you your measurement. And you would add the extra inches depending on what size rod you had. So here's a 6, 6, 5, 4, 3, and 2 inch rod. Okay, so you would add that to whatever your measurement is in here. And the way that these are changed is just lock it, and unscrew this ratchet thimble, unlock it, and the rod slides right out of the body, and you'll be able to replace it with a larger rod. And the way these are adjusted is you would have a way to accurately measure the length of this rod, okay? And the rod would be adjusted, this nut here is threaded, and they would adjust this rod so that this is perfectly 6 inches, and then that's how that all these are adjusted. And to adjust the barrel itself, all you would do is just pull it all the way out, right? Put it on a flat surface, crank it down. Usually you would use something really known to be 100% flat, like a surface plate or something like that, and make sure that the zero lines up with the line. If it doesn't, then you can turn the barrel to match it. And that's how you adjust these. Okay, so let's go to one other type of micrometer that I have in my possession. Alright, so this here is the inside micrometer for measuring the inside of a bore, or a relatively large bore. So what you have here is the micrometer itself and then these rods. Now the barrel of this is only graduated to 500 thousandths, so only graduated half an inch, which is half as much as all the other micrometers that you've seen. And you can see we have all these rods. This is a 2-inch to 8-inch set. So what you do is just take this rod and put it in here, okay? So right now it's at 2 inches, okay? So you crank this out all the way and you get 2.5, okay? But then it gives you this little collar that is a 500 thousandths, which would extend this range out here to 3 inch. So now depending on what kind of combo you got going, you can go from 2 inch to 8 inch. Each rod is labeled. So this rod is labeled, this rod here is labeled 2 to 3 inches, and this largest one's rated 7 to 8. So you can see you can get pretty big bore in here. So now, okay, so I got something big enough here to test out. So basically what you would do is choose the appropriate rod for the diameter and kind of sit this in here like so and manipulate it around. Manipulate it around by feel here like that until you feel it hitting the sides and doing what you want, and making sure that you're in the middle of the bore, and then read it. So we have this set for 3 inches right now, so with 3 inches and 25, 32 or 31. 3 inches, 31. So we can kind of confirm that with a caliper real quick. See how accurate we got it. And you can see there, 3 inches, 30. Which I was squeezing against cardboard, so that'll result in the error for it. But that's how you would use an inside micrometer. And now they come in all different flavors. I have a very, very small one here too. This one is tiny. This one's actually only graduated up to 1/4 inch to 250 thousandths. And this also has separate rods with a little lengthening collar for it. You can see how small that is. I mean, it's smaller. It's smaller than both my fingers combined, so I don't even know how you would get that into a bore to turn, but they did make it. So I hope you guys enjoyed that video, and I hope you could take away a little bit of something with it. And I hope you got kind of what I was getting at with the measurements and stuff. As far as the feel of the calipers and the micrometers and reading them, it just comes with repetition. It's not that hard once you get to doing it for a bit. As far as a video like this goes, I kind of want to get in the habit of doing one per month. I don't want to flood it out like week after week after week. I know a lot of you guys out there know what you're doing, so I don't want to bore you, but everybody that knows what they're doing, I don't want to kind of repeat everything and bore you guys to death. And I do want to do projects and things like that. But hopefully I can do one of these every month, and it doesn't necessarily have to be a bench thing like this. I can do a video on just threading and how to measure threads and things like that, just a back to basics beginning video. So if you guys think that's a good idea, if you like this, just give it a thumbs up or a comment down below, and we'll kind of get into the habit of doing just like a beginner video every month. So as far as other projects go, I do have them lined up, and we'll definitely be getting to them. I don't know exactly when, but we'll definitely be getting to them. So thanks for watching this video, and we'll see you in the next one.